The deepest recesses of our solar system may actually be home to a giant planet with a mass 5 times greater than Earth's. A year on this exile planet would last more than 10,000 years because it orbits at such an enormous distance from our sun. Recently, several teams of astronomers have been tirelessly hunting down this mysterious planet. What clues, what discoveries have allowed them to think it actually exists? Why is it so hard to find? How is their research transforming our vision of our planetary system and the story of its formation? Many astronomers are passionate about far-flung galaxies or the unknowns of the Big Bang. But closer to us, the outer limits of our solar system remain a mysterious zone filled with riddles to solve and great discoveries to be made. Astronomer Chad Trujillo is one of the world's best trackers of celestial bodies. He has co-discovered several dwarf planets, dozens of moons that gravitate around Jupiter and Saturn, as well as some of the farthest objects ever identified in the solar system. Thanks to some of his observations, the possibility of a giant planet's existence re-emerged during the last decade.
I'm a little bit of a geographer of the solar system, but it's even more than that. We're trying to understand how the solar system got the way it is today. So all of these distant objects, so they can give us clues about what happened early on, kind of like fossils of the solar system. So this hypothesized planet, of course, we don't know the exact orbit because we haven't found it yet, but there have been a number of estimates over the years, and we think it's probably around 300 to 500 astronomical units.
To measure distances in the solar system, astronomers don't think in kilometers, but rather in astronomical units. The distance between the Sun and the Earth, 150 million kilometers, equals 1 unit. Jupiter is at 5 astronomical units, Saturn at 10, and Neptune at 30. Chad co-discovered the farthest known object in the solar system, located at 120 astronomical units, nicknamed Far Out. Concerning our mysterious planet 9, it might be somewhere between 300 and 500 astronomical units, or possibly even farther.
A planet or any object that was out beyond 300 AU, it would take a few to several thousand years to orbit the sun. We don't really know what this planet might look like, but at that distance, it would probably freeze solid. So we think the surface might be very icy.
The origin of this quest for a mysterious new planet began with several major discoveries in the early 1990s. At the time, Pluto was considered to be the 9th planet in our solar system, all alone and isolated in the dark. Then, astronomers discovered that it belonged to a vast group of several thousand objects, known today as the Kuiper Belt. In 2004, in an area beyond this, Chad Trujillo spotted another object similar in size to Pluto with his partner astronomer Mike Brown. Their discovery led to Pluto losing its status as a planet.
Dear Mike, I would like to find Planet 9 and Planet 10. I don't know what Planet 10 is, but that'd be great. Jupiter with a red spot. They're about the right sizes. Saturn with a nice ring. Uranus with a sideways ring. Looks like I stuck the pin right in Pluto. I can't remember if that was on purpose. Probably it was. I still think Pluto is a planet. I want you to make Pluto a planet, and please can you do that for me? And the answer is no, I can't make Pluto a planet again. Pluto is too small. Pluto, if it could make itself 20 times bigger, could make itself a planet again, but I can't do it.
Astronomer Mike Brown, aka Pluto Killer on social media, is the author of a book called How I Killed Pluto and Why It Had It Coming. He's a planet hunter like Chad. They began their careers together with the discovery of large objects in the Kuiper Belt, and that's when all the trouble started.
In late December 2004, suddenly, as with the rest of our survey, I found a really bright object, really bright. This was the brightest object that had ever been found in the outer part of the solar system since Pluto. And this was pretty exciting.
You know, he was like, do you think this is real? And I said, yeah, it looks real to me. This is gonna, you know, this is a large object. This could be bigger than Pluto. So if we found something Pluto-sized in Pluto's neighborhood, and Pluto's a planet, then that means we must have found a planet. So that's what our argument was to the other astronomers.
So we announced that it's a planet, the 10th planet. That's what our press release from that day in July says. And that led to a year of argument about what we should do about this.
What was the actual wording of the rest?
Tempers flared as the scientific community debated this new object's status. Was it also a planet like Pluto, even if neither of them is even as big as our moon? Or should we change the very definition of a planet? The debate spread to the general public, shocking some who were emotionally attached to planet Pluto. Mike fueled the flames by naming this new planet after the Greek goddess Eris.
Eris is the goddess of discord and strife. Perfect. I love Eris. Eris is perhaps my favorite goddess, and the best possible name for this object that led to the largest amount of discord and strife in our thinking about the solar system in our lifetime.
In August 2006, the General Assembly of the International Astronomical Union was held in Prague.
In particular, 6A is concerned with Pluto and Pluto-like objects.
Astronomers from all over the world voted to downgrade Pluto's status and created a new category of objects, dwarf planets.
So the motion is carried.
Eris and Pluto thus became the solar system's first dwarf planets. Today, there are 9, and new ones continue to be discovered.
People really aren't used to seeing the actual sizes of the planets. Jupiter, big Jupiter. Saturn, even without its rings, is quite big. Uranus and Neptune, Mercury, Venus, Earth, Mars. These tiny little dots are the asteroids you can barely see. And here's the Kuiper Belt. One of those is Pluto. It's hard to tell which one it is because it's not particularly distinct. I have found that this picture is almost enough to anybody who tells me that Pluto should still be a planet. I show them this picture, and they tend to look at it and say, oh, I get it. I see that you're right.
But how big is this new Planet 9 that Mike Brown is so fervently seeking?
When we talk about Planet 9, people say to me, is this going to be something that's just a little bit bigger than Pluto when we're going to argue, is it a planet or not a planet? And the answer is no. It's probably something like that size. This really is legitimately the 5th largest planet in our solar system and a big chunk of what there is left to discover around us.
How can Mike Brown calculate the size of a planet that has yet to be discovered? His new associate and partner in the hunt for the true 9th planet is Konstantin Batygin. At 35, this astronomer, a brilliant mathematician and theorist, is already a professor at Caltech. He loves alternative rock, Thai boxing, and the complex dynamics of the solar system's celestial bodies.
So the clues to the existence of Planet 9 lie in the Kuiper Belt, in the distant part of the field of debris beyond Neptune. It wasn't one line of evidence, it was many. But the first of them really was the alignment of the orbits.
In the far reaches of the solar system, some recently discovered distant objects gravitate on some strange, very elliptical orbits, which seem to be tilted in the same direction.
It's weird, it's really strange that orbits would behave this way if there were no other sources of gravity in the solar system.
The first ones to identify this anomaly and formulate the hypothesis of a massive planet were their rivals, Chad Terrillo and Scott Shepard. These two have teamed up to discover all of the most distant objects in the solar system. In their jargon, objects that gravitate well beyond Neptune's orbit are called extreme trans-Neptunian objects. Sedna, a dwarf planet discovered by Mike Brown and Chad Terrillo in 2003, is the first of these extreme objects with very elliptical orbits. Another one, nicknamed Biden, was found by Chad Terrillo and Scott Shepard. These ETNOs gravitate between 40 and 900 astronomical units.
In 2014, we did just some basic analysis on these objects, trying to figure out how they could have these similar types of orbits. The only way we could get these objects clustered would be if we put down what we call the super Earth mass planet, hundreds of astronomical units beyond where Pluto is.
Mike Brown and Konstantin Batygin used Scott Shepard and Chad Terrillo's initial observations to make thousands of digital simulations combining these extreme orbits with gravitational laws.
Many of the simulations we run look basically like this. They start out about 4 billion years ago when the solar system is still in its infancy, when it's young and completely disorganized. If you look very, very close, there's a small circle here, a small pink circle that is the orbit of Neptune, as well as the orbit of Planet 9. And indeed, what we see is that in a couple billion years, we see a pattern develop where the surviving orbits all point the opposite direction from the orbit of Planet 9 by an interplay between Planet 9's gravity and the gravity of Neptune.
In these simulations, Konstantin used various parameters for the mass and the orbit of this mysterious planet. In doing so, he was able to explain the dynamics of these extreme orbits and mathematically estimate Planet 9's size and orbit.
If all distant Kuiper Belt objects are like sheep, then Planet 9's gravity is really a shepherding effect to the stable, distant Kuiper Belt objects that we see.
Konstantin also observed that some of these simulated objects sometimes approach Neptune too closely, causing them to deviate from their trajectories and orbit almost perpendicularly to the solar system's ecliptic plane, the plane on which all planets are aligned. These orbits would be impossible to explain from a gravitational point of view without this interaction, this interplay between Neptune and Planet 9.
Remember, we thought, wouldn't it be cool if such objects really existed, right? Wouldn't it be cool? It would be a great, prediction of this theory.
When we finally saw them, I realized they were there. I was like, Konstantin, come here. There are 5 objects, and they are on orbits that are perpendicular to the solar system, but I don't know where they are. I don't know which direction they point around the sun yet. Let's plot them. So we sat here, I plotted them on my computer. I said, here we go. I'm going to press the button. Let's see where they plot. Are they going to be in the right place? Press the button, and they're perfect.
It was that moment when I remember thinking, oh man, this is real. right? This is not just calculations. I think this might actually be for real.
It went from, this is a really cool hypothesis, this is fun, we have a good explanation, it's a good time, to, oh, there's a giant planet out there. We need to go find it.
In 2016, Mike and Konstantin began their hunt for this 9th planet and made their first observations in Hawaii at the top of the Mauna Kea volcano using the Subaru telescope, one of the most powerful in the world and highly prized by astronomers. From there, it is possible to observe a vast part of the sky visible from the northern hemisphere. So far, their search has been fruitless. At an altitude of 4,200 meters, good weather isn't guaranteed, and the scientists must adapt to the lack of oxygen. Their rivals, Chad Trujillo and Scott Shepard, started using the same telescope 4 years earlier, in addition to observations they were carrying out at Cerro Tololo, based in the southern hemisphere in the Chilean desert. Chad and Scott have a head start on Mike and Konstantin because they have been scouring several key areas in the sky for their large research project on extreme and very distant objects.
So in this image, we kind of have a map of the entire sky, and all the black points are areas we've looked for new objects.
I like to say it's like a box of chocolates. Each image we take, you never know what you're going to get in that image. And so it's always very exciting just looking through these images because we find all kinds of stuff. Anything that goes bump in the night, we kind of see it. We've discovered comets, we've discovered asteroids, we've discovered moons of the planets. So all these things are in the foreground of our images while we're looking for these very distant things in the background.
Scott and Chad have discovered a combined total of over 120 moons and satellites orbiting Jupiter and Saturn. They have found several confirmed or potential dwarf planets, including the one recently discovered at 120 astronomical units, dubbed Far Out. Yet, even for them, after several years of research, this mysterious Planet 9 remains elusive. Why is it so hard to find?
With the models that we have in place, we actually can't predict where Planet 9 is on its orbit. All we can calculate is the shape of the orbit itself. That said, it is more likely, given the other constraints that exist, that Planet 9 is currently on the further side of its orbit than it is on the closer side.
By Konstantin's calculations, Planet 9 orbits a sun in an elliptical pattern in more or less 10,000 years. When closest to the sun, it would be around 300 AU. But at its most distant point, it would be around 600 AU or more. It will be harder to find if it is currently in this area. Still, how can thousands of extrasolar planets located outside of our solar system be discovered, but not Planet 9?
People often ask me, we can find planets around other stars all the time. Why is it so hard to find a planet around our sun? What's wrong with you people? The answer is really easy. To find a planet around another star, you know exactly where to look. You go look at that star.
When an extrasolar planet passes in front of its star, it diminishes the star's luminosity a bit. This is how most exoplanets are detected, indirectly. They are neither seen nor observed optically. They are simply deduced.
If you are inside the planetary system and you're looking for a planet outside, you have no idea where to look. It could be anywhere around the sky. It's not as bad as that. We do know some idea where to look. We now know a swath on where to look. Here's a map of the entire night sky. Here's the equator of the sky. This swath is the Milky Way galaxy running through here. And this colored thing is our prediction of where Planet 9 should be. We have been systematically ruling out different areas, and most of this region is ruled out. Most of this region is ruled out. The only places left are just up in here. This is basically our treasure map that shows us where to go hunting.
This zone, located in the Milky Way, is the galactic plane, a dazzling river of 400 billion bright stars. It is the most difficult place to detect such a faint and faraway object.
Here's a normal stellar background. Here's the galactic plane. And so it's hard to observe objects in this galactic plane field. Going into these areas requires special techniques, and you can't go as faint because you got this, this bright background. But one of the special techniques we use is you take several images of the same area, and then you can subtract one image from another, and you can remove that star background. So it takes a little more image processing, a little more data to do this, but you can go in and observe. It's just harder to do.
This technique also requires more telescope time and provides limited results.
In the Milky Way galaxy, you take a picture of the sky and it's just full of stars and full of dust and everything else, and it's a mess. And if you're looking for one faint object that's moving, well, it might be blasted by a star that's in the background. So if you weren't looking for Planet 9 specifically, you probably would never look in the Milky Way galaxy. But it might be hiding there.
If Planet 9 is out there in the Milky Way, there couldn't be a worse place to look for it. Mike already knows that his few sessions with the Subaru telescope will not be enough. Faced with the daunting scale of the challenge, he decided to adopt another strategy. He thinks it is highly possible that, unbeknownst to us, Planet 9 has already been photographed.
This is all data mining, so this is all using pre-existing data and trying to find it, but it's an ugly set of data that I need to somehow work my way through.
It's entirely plausible that Planet 9 has actually already been observed, and it's sitting there in data, but the data has not been properly analyzed. That's a task that, a lot of people are working on at the moment.
Today, several groups of astronomers are tracking Planet 9. A team based in Tucson at the University of Arizona is also searching, but with a different approach.
Hey, Kat.
Hey, Renu, how are you?
I'm doing all right. How are you?
Good.
Great.
I've got some new plots to show you for the DPS poster.
Renu Malhotra and Kat Volk have contributed to the research on Planet 9, but also suspect the existence of another planet. Renu Malhotra is a theorist, a major expert on planet dynamics.
Yeah, still have a significant...
Kat Volk was once her student and is now her research partner. She is an excellent observer of the sky.
Yeah.
They suspect there might be an orbital resonance in the extreme objects that point to the existence of Planet 9. There could be a specific and regular mathematical relationship between the number of revolutions of each object around the Sun and the number of revolutions of Planet 9. For instance, while Sedna orbits the Sun 3 times, Planet 9 would orbit only twice, and so on.
Orbital resonances are really important parts of how orbits are influenced. If we could have confidence that the resonances are true, then we could locate the planet in the sky. Within a few spots, we could say that it's most likely here or here or here. Very narrow spots, we could do that.
This calculation of orbital resonances requires very accurate information on the orbits of these objects, which will take another few years of observation and verification. But that's not all. Renu and Kat have also observed something very bizarre in the Kuiper Belt.
Kuiper Belt objects have a variety of orbital planes. They're dispersed. They're not all in the same plane. Some are like this, some are like that, and they're all oriented in many different ways. But the average plane is, we expect, to be close to the plane of the solar system.
We found a deviation from what was expected in the more distant part of the observed objects. And we calculated that something like a Mars to Earth mass planet could potentially explain that deviation.
So this deviation of around 10 degrees in the average plane of the Kuiper belt could be caused by the presence of another unknown planet, smaller and closer than the one sought by the other teams. Its orbit would be located at approximately 100 astronomical units. How could it have escaped the seasoned eyes of the best astronomers who are scouring this part of the sky?
It would be pretty bright, and the only way that all our previous observational surveys of the outer solar system would have missed it would be if it were in the galactic plane. That would be the place where any planet like an Earth-sized planet at 100 astronomical units could have gone undetected.
To see more clearly, all of the teams searching for unknown planets in the farthest reaches of the solar system are impatiently awaiting the arrival of a new, giant, game-changing telescope. The campus where Kat and Reno work is home to one of the world's largest laboratories creating exceptional mirrors. Honeycomb mirrors, which are the best and most accurate ever made. Dozens of tons of glass are placed by hand, heated to over 1,800 degrees Fahrenheit, then cooled for 3 months before a lengthy fine polishing process. One of these giant mirrors traveled for 8 weeks, sometimes through high mountain roads, clearly not designed for this kind of incredible convoy that traveled from the Arizona desert to the Chilean mountains. The construction of the LSST, also known as the Vera Rubin Observatory, in tribute to one of astronomy's greatest women, is a fantastic tale in its own right. Its 3.2 billion pixel camera will be able to film the southern hemisphere's sky each night. To process and analyze all of this data, a huge data center has been built in a neighboring city. Unlike current telescopes, where there is a fierce battle to obtain observation time, the LSST will provide its data more democratically to almost the entire community of astronomers.
It's expected to discover 10 to 40,000 trans-Neptunian objects, which is compared to our current sample of a few thousand known objects. Of course, while it's surveying the sky, it should also be able to detect any new, large, distant planets. So I am really excited about the onslaught of data we should be getting from LSST.
It's going to revolutionize the way we think about our solar system, just because we're going to know so much more about what's out there. If the hypothesized planet's bright enough, then the LSST could find it. But if it's not, then it won't. So I think if you want to look for something now, you should do it and not wait until there's some future survey that hasn't started yet and hope that they'll find it.
Planet 9, before it has even been discovered, has already become legendary. Eduardo Martiret, the conductor of the Miami Symphony Orchestra, even composed a concerto in its honor. Konstantin is set to perform this unique music with them in just a few days.
Planet 9 has really captured the imagination of the general public. People have made flags for Planet 9. People have designed clothes with Planet 9 logos on them. It's a real honor to be a part of all of this.
It is March 11th, 2020, and unbeknownst to him, Konstantin is giving his last class in person before the pandemic strikes the United States and most of the world. For over a year, universities are closed, the telescopes in Hawaii and Chile are inaccessible, and the work at the Vera Rubin Observatory is delayed. The planet hunters are stuck at home. But in this celestial treasure hunt, professional astronomers are not the only participants. Guillaume Collin is a pulmonologist in the south of France. He's no stranger to COVID-affected lung scans. Besides medicine, Guillaume's passions are astronomy and science fiction.
Thanks to my profession as a pulmonologist, actually having seen many scans and images, my eye is used to seeing sequences of many images and accurately identifying what's in them.
He is part of the vast community of amateur astronomers doing their part by wading through billions of images of where Planet 9 might be hiding. The project he's participating in is called Backyard Worlds. Created by NASA, this program asks citizen scientists to examine infrared images captured by the Weiss Space Telescope.
Each black dot actually corresponds to a star. It's the infrared trace of a star. The project requires us to look at these animations and see if we see objects moving as the years go by. So it could be brown dwarfs, very close stars, or even Planet 9 that can show up like this. It's not looking for a needle in a haystack. That would be easy. Here, we're looking for a needle in all the haystacks in the world. With internet, we can access all the haystacks, and we need to find the needle, but we're not even sure it exists. I haven't discovered Planet 9 yet, but I've discovered some brown dwarfs. So I've contributed to the discovery of new stars that weren't known before.
To Guillaume's delight, his discoveries have been published in scientific journals, and NASA researchers have even credited him.
And here we see the animation from 2010 to 2019, and we see that the object gradually moves down. When we saw that, we noted the star's coordinates and sent them to NASA. They made a request to look at it with the Hubble telescope. They were able to get access, and they went to look at the star. That was such an extraordinary feeling. I'm not an astrophysicist, I'm just an amateur. And in my lifetime, I've managed to influence the course of the Hubble telescope. When you analyze a stew of pixels like that, you're panning for gold in the sky. I mean, each time you sift. You're trying to see if you can find a nugget, an interesting star. Obviously, Planet 9 is the big diamond that's always in everyone's mind, pushing us to keep going.
Participatory programs like Backyard Worlds are accessible to all and allow citizens to play an active role in scientific research. Passionate novices can become planet hunters and further our knowledge along the way. Making unexpected discoveries while actually searching for something else is a constant in the history of astronomy. Kat Volk is acutely aware of this. A year into the pandemic, she is preparing to leave for 3 nights of observation. She was able to obtain some telescope time not far from Tucson at the Kitt Peak Observatory in Arizona.
Usually, when I do an observing run, I have people who go with me, grad students or colleagues. But this time I have to observe by myself because they want to keep it to only one person in any given room or observatory on the mountain to reduce the chances of anybody spreading COVID-19. Kat
must operate the telescope alone, increasing her workload immensely and shortening her observation time. To keep the camera from overheating during the session, CAT cools its special protective case with liquid nitrogen. This time, her mission is to observe in greater detail the orbits of the extreme objects that provide proof of Planet 9's existence.
Hi, Rainu. How are you doing?
Doing okay. So what happened Tuesday night then? Were you able to get any data Tuesday night?
Rainu Malhotra needs this data to study the potential resonances between these orbits and that of Planet 9, which could help locate it.
8:45, and I have not gotten data before about 11:45 either night.
While Kat is alone at the top of Kitt Peak, the super telescopes located in Hawaii and Chile are working again, but operated remotely. Mike Brown, Konstantin Batygin, Chad Trujillo, and Scott Shepard are working from their homes or their offices when they have access to them. All of them keep searching for months at a time, isolated from one another, trying to keep their heads in the game. From his home, Mike has found a new research companion, a bear who really appreciates his lush lawn and his cool swimming pool. In Miami, the symphony orchestra, conducted by Eduardo Machuret, finally performs the Concerto for Planet 9, with Konstantin playing via internet from his Caltech classroom. A concert streamed at the International Space Station. However, the ninth planet theory is hardly unanimous. In the midst of the pandemic, a team of researchers published their doubts. In their opinion, the alignment of extreme objects that serves as a key clue to the existence of Planet 9 is due to observational bias. Kevin Napier and David Gardez belong to a group of astronomers that has found some of these extreme objects.
Okay. Telescopes can only detect things that are brighter than a certain limit. They're only observing part of the sky, only a very small part of the sky at any one time, and only at certain times of year, only from certain locations on Earth. And as soon as you can't discover everything that's out there, you have to ask yourself, what are the properties that cause objects to be discovered by our telescopes?
By taking into account all of these observational constraints, they realized that the extreme objects they had found only correspond to what they could statistically discover, and that there are not enough objects, not enough statistical data to affirm beyond a shadow of a doubt that Planet 9 truly exists.
Our conclusion was that we cannot rule out that they are indeed clustered, but there's also no evidence that they are clustered. So that's kind of a complicated statement, but the clustering of these ETNOs is not a smoking gun like it maybe was once thought to be.
Of course, in response, Planet 9 hunters dispute this analysis, saying that it is biased.
You have to look where you think there are no objects in order to find objects that break the pattern. And to date, there's been no objects that break the pattern.
Chad Trujillo criticizes them for looking at a limited section of the sky, this dark blue zone that looks like a tank.
Our survey doesn't have that bias. Scott Shepard and I work very hard to cover the entire sky all the way around the ecliptic and off the ecliptic, looking for these objects. So our survey has very low biases because we kind of look all over.
Of course, if a paper comes out and even if the paper says, we can't tell if there's Planet 9 or not, then there's always a press release, and then the press takes it up and says, Planet 9 is dead, there's no Planet 9, and then they interview me and I say, yes, there is Planet 9, and that's all good and fun entertainment. The nice thing about this, I won't even call it a controversy because it's not really even that. The nice thing about this discussion is that these sorts of things happen in astronomy and science all the time. In this case, we'll just go find Planet 9 and no one will ever have to worry about this particular issue ever again.
To end this debate, Planet 9 must be found, or at the very least, more extreme objects that would confirm this clustering. If the future Vera Rubin Observatory doesn't find Planet 9, or any other clues to its existence, the bizarre orbits of these extreme objects, as well as other anomalies, must be explained in another way, because at the moment, they only make sense if Planet 9 is there, hidden somewhere within our solar system. Astronomy is also a combat sport. There are constant disagreements, particularly concerning theoretical aspects. It's a process that Constantine is well aware of.
Who's got time? I just got time. And here, just like in astronomy, sometimes you get punched in the face, you know, and you can either fall down and say, oh, my face hurts, or you can just, you know, get back up and keep going. It's important in science too, you know, sometimes just things don't work out. You say, okay, you know, keep going until something does work out, until you land that punch. You know, so there are a lot of parallels.
Yo, warrior, come on, get up! We don't need a break, we keep going.
Sometimes, faced with new data, a hypothesis must be called into question. For Reno Malhotra and Kat Volk, the idea of another planet located in the galactic plane at 100 astronomical units now seems less likely.
One could say it's a little disappointing that the new data shows that it wasn't, that there is not such a big signature of a warp.
The deviation they observed in the Kuiper Belt using 200 objects now seems, after further analysis with 100 additional objects, to have just been a statistical fluke. There is no longer a strong indication of a planet's presence that would have caused this disturbance in the Kuiper Belt.
Statistical flukes do happen. It does happen, and people tend to not publish that usually. I think honesty is extremely important in science. It's one of the hardest things for scientists to actually embrace, because we always, you know, as humans, we always get some attachment to some ideas or some results.
On the front lines of distant objects, Scott and Chad have made a new discovery, a potential dwarf planet nicknamed Far Far Out, located at 132 AU.
Far Far Out is really interesting, not just because it's really far out, but it's also fairly large. It's probably over 400 kilometers in diameter.
Another discovery also gives our planet hunters hope. A planet similar to the one they've been looking for has been found, not in our solar system, but in a neighboring one. It's proof that planets far from their stars, with a very elliptical orbit, are indeed a reality.
It's a very distant planet on an elongated orbit, just like we think Planet 9 has. And so that says to me, again and again, like, this is not weird. The idea that we would have a planet like Planet 9 around the sun seems to be not atypical of what other stars in our galaxy are like.
Looking for this ninth planet is not just a competition between astronomers and celestial trackers who want to add another trophy to their numerous achievements. The theory of Planet 9's existence, as well as the observation of several thousands of other planetary systems in our galaxy, have completely shaken up the vision we've had about the formation of our own solar system. One of the greatest experts in this field works at the Nice Observatory, and he is one of Constantine Badigin's mentors. Alessandro Morbidelli is a theorist studying the dynamics of the solar system and its origins. Constantine was his student and has been working with him on fundamental problems for several years now. They are not putting the world to rights, just the history of the solar system.
Theorists
are the archaeologists of the cosmos. Planetologists are the archaeologists of the solar system. It's exactly the same as a modern archaeologist trying to reconstruct how an ancient civilization worked, based on the remains found in excavations, or an investigator arriving at the scene of a crime, trying to reconstruct how a homicide took place, who committed the crime, and what the motive was.
In what way would Planet Nine's existence, if it is confirmed, be the proof of a crime scene?
If this planet exists, it is very far away. Its orbit is very elliptical, sharply tilted. So it's radically different from the orbits of other planets in the solar system. Therefore, it attests to the solar system's violent past, where some planets were thrown into tilted elliptical orbits. I'm thinking, for instance, of the oblique nature of the axes of rotation of Uranus and Neptune, which are very large. The rotational axis of Uranus is a 90-degree tilt, proof that these planets suffered massive collisions.
So what exactly happened when our solar system was born? Where did Planet 9 form, and why is it so far away from the other planets? Who is guilty of exiling it? Morbidelli is working on these questions with other planetologists around the world. Today, they tell a very different story from the one we were taught 20 years ago. A new narrative we've illustrated thanks to his scientific expertise. In the beginning, 4.6 billion years ago, there was a huge, extremely dense molecular cloud in space. In this cocoon, stars were born. Our sun was formed in this cloud of dust and gas. Here, the matter became more concentrated. The temperature rose. The protostar swallowed up everything around it until it triggered a thermonuclear reaction, causing streams of gas to spurt from its poles, its first scream of existence.
We see planet formation in action, and disk formation in action.
The loaded magnetic field lines look kind of realistic. That's how I always imagine.
A disk formed around the star, a kind of matrix for future planets. The ones born in the very beginning often become the largest. Saturn and Jupiter, the two future giant planets, are the first to greedily accumulate the matter around them, carving out a groove in the accretion disk.
Our planet is forming gaps.
That's astonishing.
They grew very fast, taking only around 1 million years.
Where were the planets first born? The fastest and biggest grew in a conducive area that we call the frost line, where the dust particles were the biggest, where more accretions formed, where there was the most solid matter.
This frost line is located at around 4 astronomical units. According to Morbidelli, in this disk, 40 or so planet embryos, about the size of Mars, formed in front of Jupiter and Saturn. Behind them, a dozen other planets around 5 times Earth's mass developed. Planet 9 was one of them. For a long time, we believed that our planets were well-behaved, following the orbits where they initially formed without ever deviating from them.
Today, we know from looking at extrasolar planets that when a planet grows quickly within a disk, like Jupiter, it starts to migrate, leaving its initial orbit to spiral towards the central star.
As they migrated towards the Sun, Jupiter and Saturn pushed the planet embryos in front of them, causing terrible collisions. Most of the protoplanets that started to form between the Sun and Jupiter were disintegrated. Much of the debris was propelled towards the incandescent star. Fortunately for us, Jupiter and Saturn's migration reversed.
Actually, for gravitational reasons that are a little complicated, the two planets reversed their migration. They stopped moving towards the star and migrated backwards. This is why the Earth's spot was spared. Because it was not occupied by these giant planets, our blue planet was able to continue forming.
But as they reverse course, the solar system's biggest players, Jupiter and Saturn, caused collisions in the opposite direction. And some planets were ejected, including perhaps our beloved Planet 9.
The solar system during its infancy was not a calm environment. It was more like a billiard table where planets are flying around, occasionally colliding with one another, merging to make bigger bodies, scattering other things around. It was a complete mess. It was a beautiful mess.
If we discover Planet 9 on its expected orbit, so on a very elliptical, tilted orbit, this will prove that the solar system was actually formed during a violent phase, where the interaction between the planets was very strong. Because all planets must be born on circular and coplanar orbits, so Planet 9 could not have been born on its current orbit.
The solar system was not classical music. The solar system was punk rock.
Farewell to the idea of immutable and eternal spheres, to the stable clockwork vision of Plato and Copernicus. And what a joy for Constantine to introduce his children to this new narrative, this new paradigm.
Once solar systems are young, it's a really chaotic place. Stuff blows up, stuff collides. And look, you guys, you know what this is? This is Planet 9 getting scattered away. Yeah, you guys go catch Planet 9.
Hello. Do you think Planet 9 is a gas planet or a rocky planet or?
I think it's an icy planet with a gas atmosphere.
Except for the atmosphere, do you think it would be a safe planet to live on?
No. Planet 9 is an awful place to live. It's just super cold.
Oh. What if we all brought our warm jackets?
We'll still die.
Goodbye, Planet 9. Don't go
Watch
fast.
it get scattered.
Bye, Planet 9.
Goodbye, Planet 9. Hope you have a good trip.
Please don't leave us. We want to know more about you. We don't realize.
In the 19th century, French mathematician Urbain Le Verrier predicted the existence of Neptune, calculated its exact position in the sky, and indicated where the 8th planet of our solar system would be discovered. Our 9th planet might also be found, partly thanks to Constantine's predictions, or perhaps it won't. In the meantime, the community of astronomers knows, without a doubt, that these ejected planets, exiled far from their star, are a reality.